Okay. So welcome back to the channel. So for today, we shall be looking at prompt engineering. And then we shall be tackling that is something to do with prompt injection, which is the main content of our topic, our video today. We shall be seeing how is this prompt injection performed. Now that we have got LLMs in place, so LLMs basically means the large language models. So you have got an LLM, and supposing you're using the RAG architecture, that is Evo augmented generation. So basically means you've got a knowledge base somewhere, you've got a set of rules that are going to guide your LLM, and then you shall then want your LLM to follow those rules. But somewhere in the way you find that it is not following the rules, or someone has basically gotten a crafty way to bypass your rules. That is what we call prompt injection. So how is it done? And is it the common chatbots that we have, that is ChatGPT, DeepSeek, Microsoft Copilot, GitHub Copilot. These ones also serve the same kind of effect, that is a prompt injection. So the act of you asking questions, that's what we call a prompt engineering. That is why you fine tune your questions well. But now, if you fine tune, that is your question in a way that it's intended to bypass, that is the rules that govern that chatbot. So we are talking of chatbot in this case. That is what we call prompt injection. We shall see how prompt injection is done. We shall have a script. We shall download one from Hugging Face. We download a model. We shall use Quen, or Chinese call it as Ven. Then we shall run it within our machine. So it shall run locally. We shall run the file as it is. We shall not use Orama, just running the model as it is. Then we shall configure that is some prompts. Then we shall ask questions and see how the model responds. Then look for a way to bypass, that is the prompts that we set. And after that, we shall have a little discussion on prompt engineering and ways to avoid, especially if you are an LLM engineer. That is, you are really creating chatbots, say for a company and such. So how do you avoid that? Is a prompt injection. Look all the key aspects that you can really use. So once again, welcome to the channel. Let's dive in. So we shall begin, that is by downloading the model. So we shall download our model from Hugging Face. We shall use that as a coin, just as stated in the intro. So we shall download this model from Hugging Face. So let's begin by getting the browser and then download the model. So what I recommend us doing, so this is the browser you have. So I'm also going to pin these links, but you can basically go to huggingface.co. That's where you get a variety of models, that is AI models. These models are LLMs, the large language model. Hopefully, we shall have a video where we shall be explaining the difference between those kind of models, the LLMs mean, transformer models, the different architecture involved. We'll also be looking maybe in a later video on how images are generated by these LLMs. So let's go and download our model. So what I want us to download, that is a Quen D. It's a 4B parameter, which is thinking model. So what I want you to type is a Quen. So let's go click on models. Then the models get Quen. You can say Ven. Then let's click on this one. Then we shall click on this Quen. Perhaps this. So the model we are looking to download, it's this one. So I've got a disclaimer here. So notice that the kind of machine that I'm using, or the laptop that I'm using, has got, that is RTX. It's NVIDIA RTX 4060, meaning it has got a VRAM of 8 GB. The RAM has got RAM of 32 GB, and this is DDR5 RAM. And then in terms of storage, it's a 1 TB. In terms of processor, it's a Core i9 processor. It's one of the latest and most, and at least a powerful processor. So notice that that is why we shall be running this model, that is a Quen R3, that is 4B parameter model. So we shall not run very large models because the machine that I'm using can't really support that. So I'm looking for Quen 3. We have got 2.5 Quen 3 embedding. So it should be around this point. And it should be this one with 709. Because the model here it's 2507. So this is the exact model that we shall be using. So this is the exact model. And now we begin to decode what the model has. That is the model card. The model card is going to tell you basically the components of the model, its performance, its strength, compared to other models. Notice that this one has got linking capability. So you can see the knowledge is at 70.4. Then the reasoning capability at 65.6. Arrive benchmarking 63.6. It fares quite well, so it's a good model. So how you download this? You're going to click on these three dots and you're going to clone this repository. So make sure you have Git installed. Currently I'm using Ubuntu, so this is quite easy for me. All I need to do is to download to click on this link. Once I have that link, I'm now going to head back to PyCharm. So at the PyCharm, you can see my ID. Then you're going to paste this on terminal and it's going to download. Personally, I downloaded this beforehand, so that's why I'm not downloading it again. But basically, that's how you get to download it. Now that we have got our model, our next thing is to run this model. And before we do that, I want to show you something small on these models. So if we come here, there's some small code that is normally below here. So this code is just to inform you how you can run this model. If we go through this is from transformers import auto model cashew LLM auto tokenizer. So any model we have the tokenizer. So this is basically where the input is converted into tokens. So these tokens are basically some numbers. And then once you have got to that tokenizer, so the model will not understand the language as we understand it as humans. So it will have to be converted into tokens. Then so auto tokenizer here, it's basically to select the right tokenizer for this model. Then the second code, it's much on defining the model name, then loading the tokenizer and such. So we shall not use this code, but we shall create our own code. And that is what I want us to do. So what we shall do, we shall still that is import. We shall still import that is the first auto tokenizer in the first modules. So allow me to position myself in a way that we are able to code as we have this dialog. So let's get into the code. We shall come and say from so this one should be in small letter. So it shall be from transformers import. So notice I wrapped PyCharm because of so we has got this auto completion. So what we shall be importing here, the transform for us to use transformers, we shall import that is one auto tokenizer, then auto model for cashew LLM, just as what the model was. Then the next thing after auto model for cashew LLM, we shall now import auto tokenizer. So with that import, next we shall come and define that is the model name. So under this model name, we shall come and say model So I can use the snake keys model name. Then we are going to have the model name as a string. So for this case, our model name was Quen. So how you're going to do this, you're going to copy the naming of your folder. Like now, if I come to my folder here, you can see I have this model. So this is the exact model name that I'm going to copy. So once I have that is the exact model name, and notice that your downloaded model should be in the same directory as the script. So if it's not the same, you have to copy the entire path. Then once you have the model name, we shall then proceed, that is to utilize the tokenizer, because we need the tokenizer for basically for the model. So the tokenizer, just as I had explained, it converts, that is the tokens, text into tokens that the model can understand. So let's do that. We come here and define, that is our tokenizer. How we do that is our tokenizer is equals to, then we shall come and say that is auto tokenizer. So I want it in such a way. Then once you have that is auto tokenizer, then we shall come and say dot from pre-trained, dot from pre-trained. Then in this function we shall pass, that is our model name. So this one is going to automatically pick correct tokenizer for our model. Then next, after we have our tokenizer in place, we shall then come and configure, that is the model. So the model here, what we shall configure, it's basically things to do with the D type of the model or the data type, the device that the model shall use. Notice in the beginning of the video, I said I have, that is RTX 4060 graphics card. So that is what we shall configure in this section. So how we do that, we come and declare the model here. And then once you have the model, our model is equals to model, is something we had imported. So that is what we shall now begin to utilize. And then dot from print train. And then below here, it's where we shall now start to configure, that is the model name. We've got our model name, comma. Then the other thing I want us to configure is the D type. So the data type here should be auto D type. So how this one should work, so, just a minute, D type, we are going to set this as auto. And then the other thing we are going to set here is the device. So we want it to run on our graphics card, that is the GPU, the NVIDIA GPU. So what we shall say, we shall configure now, that is the device map. So in our device map here shall be CUDA. So CUDA is basically the software that manages your graphic card. So CUDA is a software from NVIDIA. So let's see. Then we shall, of course, come back to the next one. So the next one we shall utilize, that is a 4-bit quantization. So quantization means that if you have a model that has got a certain number of parameters, so instead of the model utilizing all the parameters, so you basically shed off the parameters that are not used. So that way you have your model loading faster and of course getting optimized. So let us see how we do that. So we shall say load. Then shall load this in bits. So I'm looking for load, that is let's go in bit. If we get that, okay. So the bits here that we shall be loading, we shall set it as true. This one should have been in 4-bit, not just bits. Then with that configured, uh, what we shall then do is now begin to give that is the system prompt. So this system prompt is what acts as the guardrails for the model. So anytime someone does a prompt injection, basically means that they have bypassed that is the guardrails of your model or these same system prompts that normally guide the model on how to respond in a specific chatbot. So in this chatbot, I shall create a chatbot that only responds to computer science topics. So this is because we are in a computer science field. So that is our main goal. So that this chatbot should not answer any question outside computer science. So how we do that? Now that you have defined all the configurations for the model, how the model should run, we shall now create that in the system. So how we shall do that is by I'm going to type it in caps. So at our system prompts, what we shall do, we shall give them as a string. I shall pass them as three of them. They should be three, not four. So this will give us an error. So they should be three, three. Perfect. So some of these prompts, I'm not really going to uh, type them, but I'm going to copy them from my script. So from my tutorial script, so this is what I had in mind. And now that we have these prompts, what we shall do with these prompts is that we shall observe the LLM following these prompts as a guide for it to answer questions. So it should not be able to answer questions outside these instructions. So with that, we shall come to create that is the main function for the chatbot to chat with us. So this one shall just be a function. Then inside this function, we shall define a few things. So one of the things we shall define is how you chat with the chatbot. So we shall begin by creating the function here, that is by def. So this should be small. So this is how we create functions in Python. And then we shall call it that is chat with yes chatbot. And then so that's how we shall call that is the function. And then below here we are going to print a couple of items. That is display the introduction so that anyone who doesn't know what this chatbot is about, once they run the script, they are going to get some prompts, that is some information about the chatbot. So basically here we shall use some simple print statements. So what we shall do, we shall have that is a print. So I'm going to copy this, going to copy it so that we can have four of them. We shall have this as 1, 2, 3, 4 of them. Then inside the four of them, we shall have that is some definitions such as computer science. So this one we shall let it be computer science. This one also we shall let it to be say a value just right. So what we shall print, we can print that is an equal sign here. And then the other thing we can also print is that this chatbot specifically only answers computer science questions. And then lastly, what we can also print is that to exit the conversation, you just type the word exit. That's how you exit, that is the conversation. So with that in place, now that you have defined that is the introduction of our chatbot to the user, what we shall then do, we shall then create that is the conversation history. So this is where we shall be storing that is a conversation, our conversation. So this is going to be a list. So a list we normally have that is a square bracket. So how we shall do this? We shall come and create that is still under this function conversation for history. Then we shall store this in an empty list. Then once we have that is the empty list to store our history, we shall then use that is the while loop. So while this is true, we shall then give some arguments. Then we shall also use that is the try and except block. So let's see, let us utilize that is the while loop. So while some of the conditions here are true, shall use this boolean info. So while true, what we shall want to say is that shall want to get that is the user input. So what we shall say is a user underscore input. And then here we shall prompt that is the user to input something. So what we shall say shall let the user know that they are the ones who should input their question. While we do that, we shall use that is the input function. And then inside this input function, we are going to define a couple of things. So we shall use that is the escape character n and u. So basically, so this is to make the word you have come up in a new line, and then that is where the user is going to type that is the question. Then after this, we shall want to strip that is all the white spaces that the user shall maybe have used. That's why we shall use that is the strip function. Now, with that, let us now utilize that is the if condition, so that in case the user will type that is exit, how will the chatbot respond? Maybe respond by a goodbye, see you back later, and such. So let's see how we do that. We shall use that is the if conditional statement. We shall come and say that is if, and then we shall want to the user input is exit. If the user input, now the user input they type that is exit, then we shall want it to be lower. So let us convert it to lower despite how they type it, equals to exit. Here we are going to the user is exit. So if it is exit, what we shall want to do is to print a statement telling them a goodbye. How we do that is by just typing the word print, and then a goodbye, see you soon. Then maybe you can have a escape slash n, and then so this is what the user is going to see. We shall want to break this. So we can either use there is break, there is continue. For this case, we shall use a break, and there is pass. So they are normally three, but in this case, we shall use that is a break. So now that is where the final statement that shall be displayed. So nothing else is going to get executed. So the next one, if the user hasn't typed exit, of course we want them to type a question. That is where we shall handle that. We shall then come and what is right, that is using the if statement. So a user input, and now in this case our user input isn't or even come to user input. If not, that is a user input. So what we shall want to do with this, we want to print, we want to tell them to type a question. Ask a question in computer science. Then, so this is to handle the empty input. So someone may just press enter when the input is empty. So once they do that, they should be prompted that they need to ask a question. In this case, we shall not use break, we shall use continue because we want it to continue executing. So what we shall do after this, we shall come and type that is a continue. So our argument up to that point are we are in a good position. Next, once we are done with this, we shall want to come and give that pass the system prompt together with the question. So the prompt is the guardrail, so we shall pass the system prompt and the question. Then we shall want that is the LLM to use the system prompt and then answer the question, then give us the answer. So let's see how we do that. So how we do that, we shall come and define, so just here. So I'm going to call it that is a prompt full underscore. Then we are going to pass it here. We are going to so we are using F because we are going to borrow that is some of these definitions we put here. For the F, what we shall do, system prompts. I think I wrote it as prompts, yes. So that is one of the things we shall be passing. Then we shall also be passing that is the user, let's see, /n/n. This should be lowercase. Then a user. So what I shall be writing here is basically the user question. So we shall get the user question that is from the user input. So the user input from this section. The user question can be passed as user input. And then once we have that, we shall then call the assistant. So let's see how we do that. And that is how we shall call that is the assistant in this section. I want to explain something small here. So we have written that is the full prompt. So the prompt here is going to ensure that the model is going to follow the instructions. That's why we are passing the system prompt. And that's why we are using F here. We are using F so that we are able to call that is a variable system prompt. And then to also call that is a variable user input. So we want to pass to the model the prompts or the guidelines and the question. So the model is going to use the tool to answer the question using the guidelines and then give the expected output. Basically, that's how RAG works. So our main aim is to see how is now SQL, not SQL injection, but how is prompt injection done. Once you as an LLM engineer, you have set your guardrails and their questions. How do you assist those questions to bypass your guardrails? So next, we shall use that is try and accept. We shall come see under this section. So try under try. What I want us to we do is that we are going to get that is the inputs. Then under these inputs, we're going to come to tokenizer. Then under tokenizer, what I want us to pass is the full prompt and return. Let's see, full prompt. So I want us to pass full prompt under that. Then we shall return our tensors. Return not returns, but basically return underscore tensors. Then what we shall do, I am trying to see an error here. So in these tensors, let's see, shall pass them as pt. So now that solves us the error, but we have still not closed that is the type. That's why we still have that error, because we need to type that is except, but that has no issue. Then we shall want to pass this to basically what we are doing here. It's we are tokenizing, that is the prompt, converting the text to a model readable. That's why we are seeing us using the tokenizer here. So that is basically what we are really doing. Now the device we want to use here is we want to use CUDA, that is our GPU. We shall come to model, and then once you have the model dot device. So with that, we are done with the tokenization bit. Then next, what we shall do is now generate a response. So we shall generate a response from the model. So we have tokenized. Now let's generate the response. What has been tokenized is that is the system prompt and the user question. Now, once it's tokenized, the model understands. We now need to get the answer to tell the model to generate. How we do that? It's generate underscore IDs. Then what we shall be passing in this, it's model dot generate. So model dot generate. Then under this, we shall be passing some of the setting, that is the temperature or the randomness or sensitivity of the model, the context length, how long should the answer be. Then we shall also be setting that is sampling. So those are some of the parameters we shall be generating under this. So how we do that is that we can use this asterisk and say inputs. But the inputs are what we shall be setting here. So this is still the same things that were in the model from Hugging Face. So there is nothing much. Maximum just for new tokens. These ones we want them to be 1024. Then the other thing we want to set is this one we can set it as 0.7. So the maximum should be 1. And then so we have got the maximum new tokens. We have got the temperature. The other thing we shall set is it should do sample. So this one you can set it to 2. And before I forget, we should have a comma. Then lastly, what we should set is the pad token ID. And this one, we shall be setting this to a tokenizer. I will ensure that there is proper padding. So we shall be setting it to a tokenizer dot EOS dot token underscore ID. So what this means is token underscore ID. So what this does is going to set the proper padding. Then with that in place, we are now in a position that is to decode that is. Notice the model will still give us in a tokenized form. We now have to decode that. So what we shall do, now that we have that in place, so that answer that has been generated, we now need to read it in a human readable way. So the answer generated is basically a response. So our response here, we shall come and use that is the tokenizer. And now at the tokenizer, we shall be passing that is a dot decode. And then what we shall be decoding is basically what we passed. So we shall be decoding that is generated IDs, that is the input, the shape and such. So what we shall write here, we shall come and say generated IDs. So what was generated here, it's what we want to decode. And then we are going to decode this so that it's readable from our heads. And the other thing we shall come here to say it's basically match on the inputs that we had. Let's see inputs. Then the inputs are what we shall do. That is input ID dot input as for ID. Then next what we shall do, get their shape. Their shape here. So I'm getting their, what I want to get is their shape. So I'll be able to decode them back to text. That is from tokens to text. So the shape here, you can pass it as one. Then what we can also do, we can add this at this point. Uh, then let's see. We now come to that is keep the special tokens as true. Normally special tokens based on the model you're using. Keep as special. So these ones we shall set them to be true. And then what we shall do is basically to strip in case it has got many spaces. The spaces at the end. Now, with that in place, the other thing I want us to do, now that we have decoded that is the generated answer, what we shall want to do is to print that is the response. Now, this response is what is the answer to the question the user asked. How we do that? We shall come and use, that is our print statement here. Then of course we shall use f so that we are able to call, that is to basically reference the variables that we used here. Then so our chatbot is going to be, and then inside here we shall want to call that is the response. So there's somewhere we define that is the chatbot response. So this is what I want us to call here. So with that in place, I think we are now in a good position. So what is now being left, or the error that you are seeing here, is we not putting those braces. So now you have printed that is the answer. Let us store the conversation history. So what we shall do here, conversation history. So we shall now store that is the conversation history. So because we are using a list, we shall append, and then how we shall append this, we shall be using, how we shall be calling that is the user input. So shall append that is for the user. Then this one should be user input. Next, conversation history dot append still f. And now in this case, we shall be appending that is the conversation history for the chatbot. So this helps in analysis for assistant. Then so the history for the chatbot is basically the response. So the response that it has been given. So that is what you shall want to append. Next, now that you have the conversation history are stored, that is, our answers are stored, the user questions are stored. We shall then limit them because of memory concerns. We shall not store very long a list of the conversation history, as it may get too huge. So let us give an if condition for that. So if, then we are going to govern that is the end. If the end, that is the conversation history. So if the conversation history uh, in this case is greater than 8, I'm going to say greater than 8. It is something I wanted to do. So what we wanted to do is to just maintain 4 exchanges. That is 4 questions, 4 answers. So how we do that is basically we shall tell it to so the conversation history. In this case, all we want is that the conversation history should be that is only for answers. So how we do that? When from your knowledge in Python, you know how we reference lists. By negative means we shall start counting from the last one towards the first one. Then let's close that is the try block. So how we do that, we shall come and close this try with except, and how we shall handle this. The exception. This is why in case there are errors that are going to arise. Before I even come to this exception, so the exception here, what we shall capture exception, we shall define it as E, and then we shall want to print just in case there are any errors. That is print. So I'll print 2 things here. So the first one, what I want to print is in case there is an error. So error, and the error here shall be basically I shall basically be from what error has arisen from the try block and from the except block. That is what we shall be capturing in this. It shall be a string. So I'm going to pass that is the string function. I'm going to pass the e because you have that's what we are passing here. That's what we are defined. Then the second one I'm also going to say that is to tell someone just in case please try again for whatever reason if there are errors that are going to arise. So now it's the final code to run this program. So the final code here we shall initialize that is the project. So how we normally do that, we normally use that is if this one should be together like that name. Then we shall want this script to be run directly. That means you will not execute it remotely. So how we do that? So I'll set it as main. And then after our if condition here, I should add this one. That's how we normally add the if statement in Python. Then I'm going to call the function. So our function we called it as this. This is what I want to run this position. I seem to have run into an error because I forgot one cosine here. So that is the code. So let's see how this is going to run. We shall run this. There are some things here that we didn't really write. Perfect. So our code runs well, and that is why you can see that is this chatbot only answers computer science question. So we have defined you using this, just an introduction. If I come and ask it what is a RAM, a RAM we expect it to tell us that is a random access memory and press on enter. So this will take some time to run because this model is quite huge. It's 4 billion parameters, and I'm using that is a graphics card of 8 GB VRAM. So it should take a couple of sometimes. So as this is taking sometimes, I just want to take this opportunity to really explain that this how basically you normally set your prompts. So these are the prompts that we are going to use. And then these prompts, once you set them up, if someone is to do that with SQL, that is a prompt injection, they are going to look for a way to bypass your prompt, this set prompt. So one of the characteristics of the prompts is that they should they should always be precise, they should always be accurate, they should be direct to the point, easy to understand. And now with that being said, we can see that we have enabled thinking and you can see that the model, so the answer is a random access memory. It's a volatile memory that temporarily stores that is data, stores the data the CPU needs quickly. So it's basically you find that the RAM it's also used basically when where you have got your hard drive and then some data is loaded into the RAM before it's passed to the CPU. So the transfer speed between your disk or your SSD or your hard disk to the RAM, that is really what makes your computer fast. So if you use an SSD, that means the transfer of data from your SSD to the RAM, it's quite fast because SSD will load faster. So that is just some knowledge on RAMs. So that's how this question works. Then if I am to ask it a question outside these prompts, how should it respond? So it should recognize that the question is outside the prompts. So I'm going to ask it another question. Maybe like how do I make so this is enough question. So it shouldn't give an answer to this. So if it gives an answer, you should know that your system prompts are they are prone to uh, that is a prompt injection. And so you not want to go to production with such kind of uh, prompts because they are going to be giving information that they shouldn't be giving. So in this case, the prompt injection, that is basically how things will really work. So this is just a directory of you calling or interacting a model, directly downloading it and using it on your disk. The other ways you can use that is using ORAMA and SAT. So the user question, what is the uh, seems the question here really didn't get it well. So let's go through this. So this is interesting. So I can only answer computer science questions. User question, how many is 2 plus 2? Assistant it's for user question. How do I cook meat? So this what we ask with the question. Then I can only answer computer science. A user what is the complexity of a root? Can only answer computer science question. I can only so that's the correct response. But you can see it's giving us kind of responses that we really didn't ask or some questions that we really didn't ask because we didn't ask about the complexity of a for loop. We didn't ask that. So all these you can basically fine tune your model to for it to be more sharp. So with that being said, that is what I wanted us to talk about how prompt engineering works, how that is a prompt injection can be done, and how what you need to do to prevent it. So to prevent this is that you need to have very strong prompts or guardrails so that your bot uh, isn't prone to that is a prompt injection. So basically, that's what I had. So let's meet into the next video. So see you soon.